All right, we have here another titration. We're going to end up using the same formula as before. Na times Va times Ma. I guess I wrote that slightly differently than before. It doesn't really matter what the order is. Equals NB, VB, MB. So let's identify what's what here. Now the first thing you might say is, whoa, where's the acid, where's the base? It's not clear cut, there's no OH just sticking out at you. So hopefully by now we can recognize that H3PO4 is the acid. It has the hydrogens out front. If it ionizes, it'll make H plus and PO4 3 minuses. That is the acid, which means NH3 is the base. So the key is figuring out these values of N. So the value of Na, looking at H3PO4, is 3, because this will dissociate into 3 H pluses and 1 PO4 3 minus. Now, what is the N value for the base? You might be tempted to also say 3 because of the 3 here, but what we have to remember is that NH3 is not producing 3 OH minuses. It's reacting with water, which is going to make NH4 plus and 1 OH minus. So NB is actually 1. So when in doubt, if you don't see clearly like MgOH2 or AlOH3, if you don't clearly see an OH with a subscript, assume that NB is 1, because that's usually all these weak bases, that's what it's going to form. So now we have everything else. We have right here, this is the molarity of the base, MB. We don't know the volume of the base, that's our unknown. We know the volume of our acid. We know the molarity of our acid. So the interesting part of the problem is kind of over. Now it's just plugging in. So Na was 3, the volume was 80 mils, and the concentration was 0.2 molar, which equals Nb, which is 1, times the volume, which will be, we don't know, times the concentration, 0.8 molar. And now just get to it with the algebra. 3 times 80 times 0.2, 48. I'm just lopping off units right now. Is 0.8. If I matched them up properly, I know the units will cancel at the end. All right, if I solve, I get 60 equals VB. And since the units initially were in milliliters, these are also going to be in milliliters. So 60 milliliters of this base are going to be required to neutralize 80 milliliters of this acid. And the reason this time is the acid concentration is really more than 0.2 if you consider the H3PO4. But anyway, this equation here will hold up at the end. You can always go back and double check that. So that is a titration, a slightly more complicated one, but really that's probably about as bad as it will get. So until next time, I am Derek Genova. Have a delightful day.